Do you want to learn how to take a monolithic script written in Python 2, convert it to Python 3 using a modular format that makes it easier to maintain? If you do, stick around. The code for this example comes from the book Blackhat Python, written by Justin Seitz, published by No Starch Press. It's a good book. His examples are in monolithic scripts for the most part. That's probably the way most Python programmers roll, right? But Python allows you to create classes, right? Now, his code for this example does use classes, okay, but the classes are easily just contained in the same script as the rest of the code, okay, along with the main method, all right? So what I'm going to do is take his code and convert it into individual modules that then make it easier to maintain, I suppose. But it's the process of going through the big script, right? Pulling out the code that goes into individual modules, how you would then use those together. That's the key to the exercise, right? And his code is written in Python 2. We're going to convert that to Python 3, which, by the way, is not a big issue. Really, the only difference between running the code in Python 2 and Python 3 is that the print statement needs to have the parentheses, okay? And you'll see that as we go along. As it turns out, there is a little bit of a gotcha in this program, and I'll show you how to fix it, and I'll explain kind of like why that is. All right, so anyway, looking at chapter 3, which is where the code is contained. In this chapter, he walks through a sniffer example, okay, where he's going to sniff packets on a machine and then print out the protocol as the packets are captured and the information about what the source IP is and the destination IP. Okay, so let's get on to the code piece here. So essentially, he starts off with this code snippet here, right? I hope you guys can see this. I've got this bigger. I can actually make the code bigger here. So let's say plus. All right, I have to adjust it a little bit more. Hope that's good for everybody. All right. So essentially, he's importing socket, importing OS, and then he creates a variable called host. All this is in the global space, okay? And then he gets in here and he says, well, let's see if we're on a Windows machine here. That's what this if OS name equals NT stands for. Okay, socket protocol. Then he sets these variables accordingly. Okay, and then, so anyway, this first example here, so what we'll do is I'll take it step by step. I will call this, since I think he's calling this Sniffer, right, I'll just call this code Sniffer, okay, and I'll call this, and I'll create a class based on this code, okay. Now, when I'm analyzing a script like this, and I'm trying to figure out what piece goes into a class. A class has an init method, right? It's kind of like a constructor. So if you're used to Java or C# or any of those other languages, there's an dunder or underscore init underscore method that Python uses. And if a class has that method, that's called a constructor, right? So when you look at a script, you have to kind of figure out, well, what part of this script is considered setup, right? And what part is code that's not necessarily part of the class, but it's part of just the script to get things to run. Okay, so in this particular case, just about everything in here, with the exception of this piece right here. Okay, well, this piece will need a little bit of deeper thought, right? because here he's just printing out the the sniffer and then the raw bytes that he gets from this particular variable right here, which is a socket. Okay, so in other words, he's taking a socket, making a creating a socket to listen to a certain protocol, either IP or ICMP, based on the value of the operating system. Okay, so now this will just print out one, right? So if you run this script, if you see how this script is organized, it'll just print, it'll run, right? The script executes, it goes through line by line by line by line, and then it gets to this piece and it prints out, right? And then if you read through the text of his book, he first checks to see if we're on Windows NT, right? So, so he does this check. If we're on Windows NT, then we're going to set the I/O control to these values, or turn it on, right? And then we're going to turn it off, right? Because he's got socket receive all, right, on. And then after this print statement executes, he's going to then check again to see if we're on Windows NT, and then we're going to set RCV all to off, right? RCV all to off, underscore off. So, so just on the back of the napkin, right, it looks to me like this code here, all the way down to here, looks like it could be in a class, and that would be the initialization method for that class. This looks like it'd be put into a method called whatever, right? Because this is where we're actually sniffing a packet. Now, it's not probably very helpful to just have a method that sniffs one packet, or it might be. But I think it would be nice to have a method that actually returns any number of packets, perhaps, right? And of course, in Python, there's probably a half a dozen ways to do that, but I'll show you how to do that with a generator. Okay, so we'll write a generator method that just sits there and returns a packet after packet after packet, depending on how many packets you want to sniff. Okay, so now, interestingly enough, I think the way I'll start this is I'll start by writing a main app Python module to kind of just fill in, like, if I were to create a sniffer class, right? If I were to create a sniffer class, how would I want to interact with that class, right? I want to have a constructor. I want to set, here we're setting a host, right? So I'd probably want to have a constructor that takes an IP address as an argument, okay? And then I'd want to call a method to actually start sniffing the packets, okay? And then, of course, this right here looks to be the code that would go into an initialization method, because really right here we're just setting stuff up. You know, we're checking the OS to make a decision on what protocol to look for, and then we're creating, right? We're creating a sniffer object, right? Well, he's calling it sniffer, right? But it's, you know, it's whatever this socket method returns, and then we're binding. Now, if you're looking at this code, you got to be careful, because this is actually a tuple, right? A tuple, however you say it, with a 2-argument tuple, which is actually a 1 argument for this bind method, right? So the bind method takes 1 argument, which is actually a tuple. Okay. So now, if you continue on, eventually we get into decoding the IP layer. This is still in chapter 3, and he gives a diagram of the IP protocol header, and then he discusses in this chapter how a C structure would look in order to capture that information. And then he proceeds to code, which is a really good example of how, and he creates a class. He's using he imports a struct library, okay? And then he creates some fields here based on the types required for the length of each of these fields, okay? So in other words, you see the IHL, header length, That's a field, right? So he comes up here, and this is the C value, right? So it's a uchar, and then it's IP underscore HL, right? So anyway, he's just mapping these fields, okay? Like starting here to offset 0. The first 4 bits is the version, okay? So that's right here, okay? That's the version. And then 4 through 7 is the header length, okay? So anyway, you could just spend, you know, probably a couple months studying all this IP protocol stuff, right? But essentially, he shows you that, and then you just go down here and you could copy the code straight from here, right? But there is a bit of a gotcha, as we'll discover, right, when we start putting this stuff together. But essentially, this is pretty easy as far as like, well, if I'm going to create a class called IP, I'm going to then just have this code here, which is pretty well defined in the IP.py Python module, right? So that's my class definition. I can turn that into a class. Well, it is already a class, but we're going to move this code into a separate IP.py module. And then we have to then take a look at kind of how he's integrating this class into his script. So what he's done was he took the previous script and then he added a class called IP, and then he modified that script to add some code. Now, this code here is all similar, so that would still be in the Sniffer program, but then he added a while true, okay, and then he's added some code here in order to, and here's where he calls the IP, or he uses the IP class. He creates an instance of the IP class, and he calls that the IP header, okay, and then he prints. Now, we're not going to print out anything from these submodules. We're going to contain the printing of anything to like a main application class, right? But for, you know, this is the thing about monolithic scripts, right? You're just mixing all this stuff, and then your code becomes very entangled, right? Very entangled. And it does take a little bit of finesse and a bit of understanding. This is a good skill. I mean, to be able to take a look at a script and then break it out into its, logical organization and components, and then create individual modules from them. Of course, you're going to have Python purists who've been doing this for a long time who probably say, "Oh, well, yeah, why would you want to do that?" Right? So, anyway, it is look, if they didn't want you to use classes in Python, they would. Why would they put them in there, right? He's using classes. That's not what I meant. He's using classes, and of course, but putting everything in one big module sometimes creates problems, right? That's not that you never want to use a monolithic, code, but the more you add to this thing, the more crazy it becomes, right? And there are some then techniques that you need to use in order to be able to have this code in separate modules, and it's good to be able to understand like how to solve those problems, right? So this is just a good exercise. The final section of this chapter, he talks about decoding ICMP. And again, it's pretty much the same drill. He introduces a new class called ICMP. And now, you're left, if you're kind of a beginner programmer, you're like, you see this code sampling goes snip, IP class structure, snip, right? So in other words, what he's saying is, I'm just getting rid of this stuff in the previous script prior to this class IP declaration, and then I'm getting rid of it. It's not that it's not in the code, right? It is simply because he's trying to just unclutter his listing here, right? So just for uncluttering purposes, he's going to kind of reduce what you see there. All right, so then he goes on, right? So he declares the class ICMP. Of course, he gives a good explanation for all this stuff, right? It's a good book. Then he declutters again here. Then he prints out this stuff here. Now, again, like, right, he's got these print statements embedded, and it does pose a bit of a challenge, like where to handle this stuff, right? And then he gives you an example of these outputs, which is good, right? Let's go back to the previous. We know, based on his examples, like, well, what are we going to be taking a look at? What should we expect as an output from running the program? So here's, based on the first, so there'll be 3 phases, right? The first phase will be create, bust out things in separate modules. We'll work on the main app, the Sniffer class, or the Sniffer class, right? Now, there is no Sniffer class in his code, right? His whole program is the Sniffer. So what I'm going to do is I'm going to create a Sniffer class, which will then use the IP class and the ICMP class, and everything will be run from a class that I'm going to call main app, right? So let's take a look at that. Organizational structure. You saw that in the introduction. So here is, eventually all his code ends up in what I'm going to call sniffer.py, right? He calls it various names throughout the process of implementing it in this chapter. And of course, it's in Python 2. And really, about the only thing that's unique to Python 2 in his example is the print statement. We can easily convert that to Python 3 version of the print statement. But when we're finished with this conversion, there'll be a main app py down here, a sniffer.py, which is where a lot of his, there'll be a class called Sniffer, okay? So I'm turning his primary program into a class, and then I'm going to take his given classes, put them in separate modules, and then use them in sniffer.py and run everything from main app.py. Okay, so that's pretty much the analysis of how we're going to accomplish this. So now I'll start with main app.py and the sniffer py, and we'll get that running, which will then, when we're finished with that phase, we would, when we run it, we should see output that looks like this down here. Okay, this is the raw output from capturing the raw bytes on the wire. Okay, so like I say, this is a good book, so let's get started with the main app and sniffer.py. To implement this program, I am running on a Mac, and I will use Sublime Text. Sublime Text Editor is a great text editor. Let me pull it over here. All right, so here we go. Now I want to make sure this text is big enough so you guys can see. I know I'm running at pretty high resolution here. So let's just make it that we can see it, right? All right, so get rid of that one. Don't save. Okay, so file new. Whoops, all right. Get back to Sublime Text, file. All right, there we go. All right, so also, too, I need to create a directory. So the other thing that I'm running is I'm using iTerm. Doesn't really matter, right? You can use any terminal. Let me make my text bigger here so we can see it. You guys tell me when. Can you see that now? Just about there. Just about there. All right, I think that should be good enough right there. Oops. All right, it just keeps going. It's buffering those clicks. Let me go down just a little bit. Just a little bit, not quite so big. Okay, now, so I'm also what I'm using is virtual environment, virtual env. Okay, so there's a whole separate video that I have out there on how to install virtual env. It comes in handy when you're doing multiple projects and you're trying to keep libraries separated and you need to install different libraries. But so let me just navigate to my Python development directory. So cd dev/dev.python. I have Python 3.7.3. I do a directory. We can see my virtual environment here. Okay. So in order to activate that virtual environment, I'm going to say source. Now this is on, I think, Linux and Mac, right? env 3.7.3 /bin /activate. Okay. Oh, hang on. env3 source. Make sure I got everything right here. Okay, I just had to pull my head out of my butt. Okay, all right, so now we've got, I've activated my virtual environment. So now let's go to projects. I'm going to go to my projects folder. Okay, and I'm going to create a Sniffer directory. Change to my Sniffer directory. And clear the screen. Okay. I can choke this down a little bit here. Okay, so. Alrighty, now we're ready to get started. So the first class I'm going to create is, I'm going to save this. I'm going to go to my Sniffer directory, users. Swodog, dev, Python. This part I can't make bigger. Projects and Sniffer. Okay, so I'm going to save this as main app. So of course you guys know, right? Python modules, which are the files, right? All lowercase by convention. Main app.py. And while I'm at it, I'm just going to create another file, new file, file, save as. I'll call this sniffer.py. And we'll start from main app. So in the main app program, I'm just going to assume I have this, right? Sniffer module. So from Sniffer, import capital Sniffer, right? Because that's going to be the name of my class, all right? And I'll come down here and I'll say def main Sniffer equals Sniffer. And I'll give it an IP address, but I'll just do this, which will mean any IP address. Listen for any IP address. And then I'll say I'll say headers, headers or packets. We'll go headers. Packets. Let's do packets, right? Because the first thing we're going to get is packets. And we might change this later on, but anyway, packets equals Sniffer dot sniff, right? All right, packets equals Sniffer dot sniff, and then come down here for packet in packet and packets, and then we're going to print. We will just say print packet, and that's just to get it started, right? So the way this well, let me finish this up here. So I'll go down here and I'll say if name equals main. You guys know what this is, right? So in other words, if we're running this module and its name is main, then call the main method. I pretty much like to do, start all my programs, structure them around this kind of main app thing, or module, I should say. Save that. Now we can't run this because we don't have a sniffer module. Well, we do have a sniffer module, but there's no sniffer class in it yet. We don't have a sniff method, right? So let's see. I think I'll make this 2 F's here. Sniff. You know what? I never thought about it much. How do you spell sniff? Let's go here. File, new window. I guess, I just probably not a great speller. Let me check that, make sure I'm getting it right. Sniff. Sniff. Or sniff. Right. Sniff. I'll come back with some kind of like Wikipedia. Oh, sniff. It's 2 F's, right? All right. Just make sure we got our sniff method named right. All right. Let me go back to my code. And, right. Okay. I changed it to sniff. So, well, here we go, right? It was like sniffer. So sniff, right? Okay. So packets equals. So what this method is going to do, this is going to be a generator method. I think, and then the intent would be here. I'll feed in, like, let's say I wanted to run 100 packets, right? I just want to sniff 100 packets, right? Or if I wanted to sniff 10,000 packets, right? Or 1,000,000 packets. Or, later you could change it to like, well, just sniff while everything's true, right? Something like that. But here, I'll just test it with a couple. All right, so what this is going to have to be, this is going to have to be a generator method. Well, I'm going to implement it as a generator method, as we'll see here in a second. But this will return this will be an iterator or iterable type, right? Because we're going to then use this packets, right? It's going to be like a list, and it'll say for in this for statement for packet in packets, print the packet, okay? And that should give us this output here, right? We're looking for this type of output. Now, the time has come to dive into the sniffer class. So we're going to pretty much copy this code, but we're going to create a class, right? So import socket, import OS. Let me go ahead and get my window here. I'm going to make this a little bit now smaller, like this. Okay. And I'm going to bring it down so I can look at this code in the background. So I'm going to go to sniffer.py now, and I'm just going to type this stuff in. So import socket, import OS. Oops, OS. Okay. Now def, right? So, oops, right? Class sniffer. And it's not inheriting anything. So sniffer, okay. Oh, okay. So next thing I'm going to do is define a init method. So this will be the constructor. Of course, it's a method, right? So self. And I'll say host, or yeah, host. I'll use the terms, right? So I'll just, whatever term he's using here, it's host, right? I'll use that term and those variables. That way you see the mapping between the original monolithic script and these classes. So host, and then this rest of this code pretty much comes in. So we will just say if, first off, his first test is if os.name equals nt. So he's checking for windows here. And then if that's true, he's going to say socket protocol. I'm going to call this self. Well, is there any need to? I could say self. Socket protocol. Self.socket protocol equals socket. Just in case we needed it. Dot IP proto. Ooh. IP proto. Else. Else. Socket. Self.socket. Protocol equals socket. IP proto. IP proto. Oh, I'm sorry. You know what? I'm not quite done here. So IP proto. This will be underscore ICMP. Sometimes when your text is too big, it's hard to see what you're doing. All right. So IP protocol ICMP and then IP, right? So just looking here at the code that he's got up here, you can see my cursor a little bit now. Else socket protocol equals socket dot IP proto underscore ICMP. And then the next thing he does, right after this, in the still in the he says self dot sniffer equals socket dot socket. Okay, socket dot AF INET socket dot sock underscore raw, and then self dot socket protocol. Okay. Then he has a sniffer dot bind, which we've called self dot sniffer. Okay, self.sniffer.bind. And then remember, this is a tuple. So this will be host. This is coming in from the constructor, host, comma, 0. Excuse me. Okay, next line, sniffer set socket. Self.sniffer dot set socket. Set sock option. So it's set sock SOCK OPT. Set sock opt. Socket IP proto IP. Okay. Socket dot IP proto dot IP. All right, comma, socket. Ooh. Socket. Let me scroll up a little bit so you can see what I'm doing. All right, there's no way to scroll. Okay, socket dot IP underscore HDRINCL. Okay, HDR increment or something like that. 1. Okay, so that was this line of code here. Now I'm on 2. And that's pretty much it for what I think is going to be in the constructor method. This here will be in my sniff method. Okay, and I'm going to make a little bit of a modification here because I just don't want to print out one value. I want to return a number of these packets, right, from this generator method that I'm getting ready to write. So let's go back here. So now I just have to, so looking at this code here, right, I'm in, so here's sniffer, right? So yeah, so if I didn't put self.sniffer, right, if I didn't put self.sniffer, then sniffer would only be local to this constructor method, right? That's the reasoning for self here in this case. So come back up here, come down, back over. Now we're going to define a method called sniff. Self. Let me spell self right. Ooh. And I'll give it a count, perhaps, right? Maybe that's the name of it. Okay. Let me just come down here with a bunch of spaces. Okay. So now I'm on 3, right up here. I'm going to start implementing this code. Okay. So let me scroll up a little bit so we can see it all. Come back to Sublime. All right, now move up. Okay, so I'm in my sniff method. The first order of business is we're going to say if os.name equals nt. Okay. If that's true, then we're going to say self. Oh, I gotta line my fingers up on my keyboard. Self.sniffer. Okay. Self.sniffer dot IO control IOCTL. Okay, IOCTL. Socket dot SIORCVALL, comma, socket. Oh, oops. Socket dot RCVALL. Receive all off, right? Oh, I'm sorry. I'm up here. I'm reading the last line, so this will be receive all on. So I'm on 3. So let's just read that again. So self.sniffer.ioctl, and then socket SIORCVALL, and then socket.RCV, right? That pays to trouble read your code. RCVALL underscore on. Okay. So we're just doing that check. And then we're going to, and then in his example on line 4, on this little 4, right, line 4 here, he then just prints, right? Well, I don't want to just print. I want to say for in for let me see, yeah, for in range 0, comma, count. So I'm going to step through this count. So when I call this sniff method, it's going to have a count, like sniff 2 packets, sniff 5 packets, sniff 1,000 packets, right? So I'm just going to have a for statement here, and then I'm going to simply do yield. Okay. Self.sniffer. Okay. RECVFROM. Hang on. Self.sniffer dot RECVFROM. Okay, and then 65565. 65565. So pretty much I'm taking his code with the exception of this for statement, right? And the fact that this sniff method has been created and I'm turning it into a generator method. Now I can take this and copy it, but I have to make sure I don't introduce spaces. Put that right there. Let me just do this. And then do this, just to be sure. Okay. And turn this off. This is just a Windows check. And that's the end of his script. So what do I have here? Let's go up and look at the whole thing. All right, stretching my window out here. Scroll up. I have a class. Well, I'm importing socket, right? According to his code, he imports socket. Let's go down here. Okay. So import socket, import OS. And then I created a class called Sniffer. Def. I created a constructor. So this is the constructor for this class called Sniffer. I'm going to pass in an IP address. I should just call this host IP so that we know what host is. Okay, so host IP. Where am I calling that? Host. So that'll be a change. Let me just make this lowercase. Host IP. Okay. That's a little bit of a change, right? He was using the variable host. All right. Up here, he said host. Okay. And then he checks for Windows NT. If it is, he sets socket IP proto IP. Otherwise, he sets socket IP proto ICMP. And then he creates the sniffer variable, except so his is a monolithic script, right? So if you're not, so mine is a class. I turned this code into a class. And so I'm using self.sniffer because in my sniff method, I need to access this self.sniffer, right? So what is self, right? Self.sniffer is an instance variable of the class sniffer. And so I need to have access to this variable, the sniffer field. I guess you could call it a field, right? It's an instance field. I need that in this method here, right? So if it's an instance field, then I can access it right outside of this method. If I didn't have self here, just as a review, then sniffer would only be visible inside of this constructor and I wouldn't be able to access it here, which is not, that wouldn't be very helpful. So now let's try running this thing. Okay, so we're going to run this. We already have the main, right? So here's how the main method looks, right? So we're going to import from sniffer, we're going to import the sniffer class. We're going to then use the sniffer reference here to call the sniff method, and we'll pass in 100, okay, for the for a test, right? And then this for statement will say for packet in packets, okay, print packet, okay. So let's see if it works, right? And what we're looking for is this output right here. We're looking for this output. Ding, ding. This looks like gobbledygook, right? It's just raw bytes. So in order to run this, let's pull up iTerm, right? So I'll do a dir. I have my main app there. So now I'm going to say sudo, right? Well, let's see what happens if you don't run sudo, right? Let's go Python. First on, just to verify, in my virtual environment, it says it's set to 373, right? So let's just verify Python version. All right, so Python 373 it is. All right, so we're going to say Python main app py. Now that doesn't mean we don't have any errors. Oh, okay, so it says line 6 socket. I'm trying to create the socket Python 3 socket self family type proto file number. It gives me this permission error, right? So if you get that when you try to run something like this, then you have to do sudo. This doesn't mean we won't get other errors, right? We have to. This is the first time we're actually running it. Sudo Python main app .py password, right? Okay, now it's just sitting there waiting, right? So it's waiting for something to do. So now I have to pull up another window. So let me open up a new window. Okay, now I don't necessarily need to make this one as big as that one, but essentially, let me rearrange them. What I'm going to do is I'm going to do a ping on my Warrenworks site, warrenworks.com. And okay, so it looks like it's working, right? So it's pinging. Over here, it's pinging, right? And so when I'm doing that ping, this is the result. Now, this should run for 100 times. And then probably we don't want to sit here and watch it run the entire 100 times, right? For every time it pings, it'll come back with a response. So let's go ahead and stop the ping, right? And just show you this generator method. Control C. Let's go over here now, do a Control C. Okay, now let's reduce, just for testing. Oops. All right. Let's reduce this from 100 to 10. All right, that's a little bit more palatable. Let's run this again. Sudo main app. And then ping. Now 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's it. So it exits, right? It sniffed 10 packets, right? So then that's it. So Control C on the ping here. Okay, that's the first. That was the first phase, essentially, of implementing the code, right? So I took his example from his first section in chapter 3, which was just this script, right? I turned it into a class, Sniffer, added a method called sniff, and then added a main app to run it all. And here is the code here. All right. I'll post links to this code if you want to check it out on my GitHub site down below. Okay, when I'm finished with this video. All right, so from here we go into the next section. All right, so if you need to take a whiz, take a break, go get some coffee, get a Pepsi, who cares, right? Go get it, take a break, right? We'll be right back and we'll start doing decoding the IP layer. So stay tuned. Okay, let's implement the next section of Chapter 3 in the book Blackhat Python by Justin Seitz. Decoding the IP layer. As I said in the intro, he provides this diagram for IPv4 header structure, and then he gives a C struct definition or declaration here, just to kind of demonstrate like how it would look in C if you were to implement this, right? So we can just jump down here to his IP class, which will be then another module that we'll implement in the conversion that we're in the process of doing. So let me open up. All right, so I'm going to create another class. So in this section of the video, we're going to implement the IP class, and we're going to then integrate it with Sniffer. Okay, so I'll create a new file, save it as ip.py, lowercase. Okay, and I will choke up a little bit, right, so we can follow along the code. Let me drag this down just a bit, and we can come up here. There we go. All right. So first off, we're going to import socket. Import OS, import struct, and from C types, import star. Okay. Now this is part of the sniffer, right? So we don't have to repeat that. So we're just going to get right into this class. Now he makes it pretty easy here, right? This is the class IP. So everything here, you would pretty much just copy verbatim, okay, including this right here, right? So everything under that, everything from the class declaration, right? IP. Now here he's extending structure, which is in this struct library right here, right? So we just copy everything here, and that becomes our IP class in the module, right? So he's already done that work for us. And then this, right, like his comment, right, that says this should look familiar from the previous example, which it does, right? So this this is already in the Sniffer class, right? We converted his script to Sniffer class. So all this here is in the Sniffer class constructor. This here is where the sniff method starts, right? So we're going to modify the sniff method and add this line of code, right? We're going to make that. We're not going to do the while true because we're doing a for statement that sniffs on a number of packets, whatever the number is, as you recall from the previous example. And then we're going to create, we're going to add this line, and then that's it. So really we're going to add maybe 2 lines of code to the sniff method in our sniffer. Okay. Other than that, because here's where he's calling the IP, right? He's calling, he's creating an instance of the IP class right here. So essentially, we're going to, let's go back to our PowerPoint diagram for the architecture, right? So we're still in the middle. All his example is just creating one big script. We're walking through his chapter 3, taking what he's creating as one big script. Now we're going to start working on the this IP class, okay, which he's already defined for us. We're just going to put it in a separate module, and then we're going to integrate that with the sniffer class, and then we're going to make a modification to our main app.py to then run the program. Okay, so let's get busy. Okay, so I'm going to pull up my code, and I'm just going to start right here with this IP. I'll pull this over this way a little bit. I probably don't need it quite so wide. You know, this is all about the feng shui, right? You can't code if you don't have your feng shui swinging the right way. Okay, so class IP extend structure. Again, right, we're converting his Python 2 code. All right, now this is a single underscore fields. Okay, this is important. If you put field, if you forget to put this S, then it doesn't work, right? So this is underscore fields. Okay, and this is a list equals list. So we may as well go ahead and we can come down here. All right. Now IHL. IP header length, I guess is what that stands for, IHL. Okay, so let's make sure that we're doing it the right way. IHL, comma, and I'll tab over here. C underscore UBYTE, comma. That's an unsigned byte. Okay, comma 4. And then, so that's a tuple, right? Or that's a, well, that's not a tuple. That's kind of like a, I guess you call it a, yeah, that's a tuple. All right, so then we come back down here. Version. Oops, sorry. Version, comma, C underscore U byte, comma 4. Okay, now we're going to get into the swing of things here. TOS. And then that'll be C unsigned byte. Okay. You know, so while we're implementing this thing, know we're talking about Python programming here, but if you're ever wondering, like, if you're looking at the C underscore U byte and, you know, wondering what's all these bits and bytes and stuff, and you're just not necessarily comfortable with it all, then you might want to, probably take a course in assembly language. Yeah, you could take a course in C, right? So lang equals C unsigned short. But assembly language, okay, is a great language to learn if you want to learn how a computer actually works. Right, so that's my plug for assembly language. I find it kind of hard to type and talk at the same time, especially if you don't want to make a mistake. Okay, if you guys see me making a mistake, shout at the computer. I might hear you. Okay, so let's just go through IHL. So C underscore U byte, C underscore U byte, C underscore U byte, C underscore U short, C underscore U short. Now these types will have varying lengths depending on the operating system version and hardware that you're running on. So there could very well be issues with, like, will the program even run, even though it's Python, right? Python's supposed to be portable. So C offset is C underscore U short. So, and then if you don't have understanding of, like, how bit lengths or word length on your machine, you might just be at a complete and utter, like, all stop and trying to figure out a solution for something that doesn't work, right? Okay, so you might be wondering, well, why am I saying that? TTL, so C underscore U byte. Okay, U byte. Well, because actually there's a bug in this program. I'm not so sure it's a bug, but there is an incompatibility between the code that I'm typing in. This will work fine if you're on a Windows. If you're doing this on Windows, this stuff runs like a champ. Protocol underscore num. You got to be very attention to detail when you're doing this stuff too. Tab, so C underscore UBYTE. Okay. Now let me scroll down a little bit. Let me come down here. There we go. Protocol num sum comma tab C U short. Okay. Okay, so src, almost done here. Tab C underscore U long, and then destination, comma, tab C underscore U long. Okay, so we have, I can come back up here, get rid of that. So then just do a check, right? I'm gonna, in order to make it easier to read, I'm gonna do another tab out here just to make sure we can see it all lined up. We will verify the field names. So now using the ctypes library, these actually become like instance properties on this object, on this class, or on the object, right? When you create an IP object. Okay, so let's just go down the list. So IHL, comma, C under U byte. Now, if you don't spell it right, and you try to access it in your program, you'll just get an error. Version C underscore U byte for TOS, C underscore U byte without a number. Length LEN, C underscore U short, C underscore U short for ID. Offset, C underscore U short, TTL, underscore U byte, C underscore U byte. And then protocol, PROTOCOL, protocol num underscore U byte, sum, C underscore U byte, source, C underscore U long, dest, DST. Okay, now we're ready to proceed with the rest. So he provides these two. This is a new method, and this is an init method, right? So here's your constructor. So we're going to just implement these guys pretty much straight up, just like he's done here. He's done a great job creating these classes for us. All right, so back here. Okay, so scroll up a little bit. All right, fields. All right, so we'll do def. New. We'll start with the new one. That's the first one. Self. Socket underscore buffer. Equals none. Oops. Okay. Okay, then what he does is returns self dot from buffer copy socket buffer. Okay, and then let me put some more here. Now we'll do the constructor method. Def init self socket buffer equals none. So you know this equals none, right? That's just a default value. If you didn't provide a value for socket buffer, you would say none, right? So all right, or it would provide a a null value, right? I guess none means null. All right, so now we're just going to create this map object, self dot protocol map. Okay, equals, and this is a map, right? So 1. So we're just mapping these strings ICMP based on protocol numbers, right? So protocol number 1 is ICMP, comma 6 is, and this is going to be used in the program, TCP, comma, and then 17 is obviously UDP. Okay, UDP. So that's the protocol map. Next is self source address. So we're right here on number line 2. Self source. So he's creating a new field. Source address equals socket.inet. So INET, okay, underscore NTOA. So struct. Ooh. So struct dot pack. So you'd have to figure, in order for this thing right here, this means a little Indian L. I'd have to look what L means again. But you go look it up in the struct library. Okay, it'll explain what that first argument is. Okay. Self.src. Now, self.src is referring to this right here, these fields, right? So this, with the C types, these turn into instance fields, right? So self.src is what he's referring to right there. Okay, self.src is this value right here. That turns into self, right? Those fields. And then we'll say self dot dest address, dst address equals a socket. We can just copy this piece right here. All right, save some typing. I got the birds singing outside my window. It's a good day. All right, dst. So now let's just check, right? So self dot source address, or src underscore address, equals socket dot inet underscore ntoa. That's a method called so struct.pack. Okay, we're giving it an argument here, and it like I say, the structure library pack method expects an argument here in this format, right? So there's different ways. Like, for example, that's little Indian. This would be big Indian, right? Go back to go to the pack library, right, to get more information on that. And then finally, here where it says try self protocol equals protocol map. So we're gonna, that's also part of the constructor. So I'm going to say a try, because evidently it might throw an exception, right? Okay, so try self dot protocol equals self dot protocol map. Okay. Self dot protocol number. That's that field, right? Protocol num up there in the fields. Okay. Now, if it's not in there, right? So except, then just set self protocol equals str for self.protocol num. So we're just going to convert whatever number it is, right, an integer to a string. And so if you see just a number, anyway, when we run this, you'll see what I'm talking about. Okay, so this is the IP class. Let's take a look at the whole thing in its full glory. All right, so none of this code, we didn't create any of this code, right? We just typed it in as he had provided it in the script. But what we did do was we put it in its own module called ip.py. We're importing socket, OS, and struct libraries, and then from ctypes, we're importing everything. This fields, right, is part of the ctypes. Well, you know, this is how you declare byte level C style structures, right? So self.ihl is that's exactly what that means. Self.version, self.tos, right? These are all instance fields in this class called IP, and it inherits from structure. Okay, and then we just implement it straight out of the book, right? So this is the IP class. Now the next thing that we do is we return to Sniffer. Let me shorten this up a little bit. Okay, and we're going to scroll up. So here now we are out. So now this right here, okay, so this is part of the Sniffer class, right? This is Sniffer. That's part of the Sniffer constructor. That's part of the Sniffer constructor. So let's pull up the Sniffer constructor. Sniffer, right? So here we have, right, this part right here. So here, this is that code, right? And we're setting the either the protocol to IP or ICMP, and then we bind, right? So there's the bind, and then we set sock options, set socket options. That's the last part of the constructor. And now we're down here in this begins our sniff method, this line right here, right? So essentially, we're going to take this sniff method. He's made some modifications. Now we can modify the sniff method on the Sniffer class, and we're going to add in the for statement. Here he has a while statement, but we're going to ignore that. In the for statement, we're just going to implement this line of code and implement this line of code. Okay, and then it is still going to be a generator function. And then we're going to take this line of code and we're going to integrate it into the main app so that we can see this stuff run, right? And none of this, all this stuff remains the same. The only thing that we're doing is he put a try. Now we could probably do that in order to, I'll go back and do that later, but we'll just go ahead and implement this piece first. All right, so we go back to Sniffer. All right, so down here in the sniff method, so we see where he's testing right up here for the NT, right? So I could just come down here, create a line, separate those out a little bit more. Okay. I'll go ahead and put the try. So I'll do the try. I'll have to tab over. So what is he doing? He's going try, except keyboard interrupt, right? So he's pretty much just ignoring the keyboard interrupt. So if we do a Control C, it's just going to hide that error that you get when you do a Control C to exit out of the program. So we can totally do that. We're just going to go right here. Okay, so try. Okay, and then here, I do this to make sure that I get my space right tabbing correct for the program. And then from here, just come down 2 or 3 lines, except keyboard interrupt. Okay. All right, so then I guess he's moving this underneath of there. So, all right, let's do that. Oops. Okay. And we have to move this underneath of there. Alrighty. So now it's structured the same. Now we're in this for statement instead of the true, right? The while up here. So he's got while true. I have for n in range 0 because my sniff method takes account. Yield self.sniffer, but what we're going to do is we're going to do this. We're going to say raw buffer equals self dot sniffer, right? Which is pretty much this line of code right here, right? Self dot sniffer dot recv from 65565, and we're just taking off the first one of those. Okay. All right. So the first element from that call. Then what we're doing, let's get rid of this statement here, right? So then we're going to say IP header equals IP. This is where the IP class comes in. IP raw buffer. Okay. And he's doing a slice 0 through the first 20 bytes, I guess. Okay, so yeah, it says right here in his comment, create an IP header from the first 20 bytes of the buffer. Okay. Yield IP underscore header. All right, so that pretty much is the way you would interpret what he's doing here. Now this print protocol, okay, so what we're gonna do is we're gonna take this print protocol string, right, string. This is just a formatting, and he's going to print the protocol, the source address, and the destination address. Okay, but we're going to put that in the main app. So save here and then go to the main app. Now here I have packets, right? I'm going to call this headers because now we're returning an IP header. So I'll say for header in headers. So, really, I mean, okay, so this is an interesting thing about abstraction in programming, right? So we create these abstractions, variable names, class names, method names, right? At this point, the abstraction is a header. We're returning headers. I could have left it the name packets, right? But packets totally doesn't describe what we're dealing with at this point, so I'm changing it to headers. And now I'm just going to take his code right here. See where it says IP header? Well, I'm just going to call this headers, a header. So I'm just going to copy his code pretty much directly, but I'm going to just change one thing. I'm going to say print, right? He's got protocol here, right? So protocol. I'm taking line 5, essentially what I'm doing, right? Right up here, he's got line 5 right here. That's what I'm working on right now. All right. So protocol, colon, %s, %s, and then %s, quote, %, and then we have, okay, so now a header, right, dot protocol, header dot src address, header dot dst underscore address. Okay, everyone see that? Let me stretch this out a little bit so we don't get too much scrunching up going on. Okay. So you're asking yourself again, probably, right? Because if you're following along kind of halfway, where's this destination, header.destination, right? So header, the sniffer.sniff method, let's go back to sniffer, returns an IP, right, object. In the IP, declares these fields. At first it has a protocol map. Second, it has a source underscore address and a destination underscore address. These are the fields that we're accessing at this point in the main app, right? So we're just taking each one of these header objects that the sniff generator method returns, right? And then going through each of the objects, I call each object in the headers iterable list, right, is a header, right? And then I'm just saying header.protocol, right? Header dot, now where's protocol come from, right? So let's go back to IP, right? We've got right here, right? This is the self.protocol. So what he's saying is, hey, look, this protocol is either going to be one of, he's got this map up here. If protocol number equals 1, then we're going to return ICMP. If protocol number equals 6, we're going to return TCP. If protocol number equals 17, we're going to return UDP. Now, it doesn't mean that in the future we can't look for more protocols, right? Okay, so now we're at the point where we can run this. What's the expected output? Here's the expected output from his book, right? His book is saying that we're gonna see this protocol, UDP, whatever, right? Depending on what we do. Now, this if this is running on Windows, you'll see something like this. But then he says, look, if we're on Linux down here, because we're not going to be on a Windows, remember we do that test, right? Whenever we call the sniff method, let's go back to sniff. We call the sniff method, it says, hey, look, am I on a Windows NT machine? If so, go into promiscuous mode, I guess is what that's doing, right? But if I'm not, right, I'm not going to see all these things. So essentially, he says, well, you'll just see this ICMP, right, on a Linux machine, especially if we do a ping, right? Because we don't, evidently we got to do something else, which is like the third section or the last section of the book, right? Anyway, so let's run this thing, right? So at this point we can test it. Let's go in. Let's do, let's just go ahead and run main app, password. Okay, now we're just waiting and let's do a ping. Okay, now it says, oh, okay. The name IP is not defined, so hang on one second. Control C. All right, so in the main app.py line 8, main app.py line 8 for header and headers. So we're in Sniffer. Oh, okay. So see this right here? It says IP not defined. Hello. Let's go back to Sublime. Let's go to Sniffer. Now we're calling IP right here. So I have to come up here in the Sniffer and I have to say import. No, I'm going to say from IP import IP, just like that. Okay. Save. Now let's run it. Sometimes it's good to see errors, right? Because if you don't make any mistakes, you have no you don't really learn. Honestly, you learn when you make a mistake. You should learn from your mistakes. Now we're just sitting here waiting. Let's go ping. Return. Okay. So we get this. We get another error here. Okay. Control C. And it says buffer size too small, 20 instead of at least 32, right? So before I spill the beans, let me just go ahead and troubleshoot this as if this was the actual error. All right, this is an error, right? Based on the way the code's written. But remember, I copied this stuff straight out of the book, right? So up here was the IP. I'm using these types as he specified, right? I'm running on a Mac. Okay, I'm running on a Mac. And I'm getting this error, which says that buffer size is too small. So this is coming from IP line 22. So let's go to IP line 22. Okay, so we come down to IP, line 22. Well, right, it says it's coming from here, right? But let's trace that back up again. Line 18 and Sniffer, right? So we go to Sniffer, line 18. You know, this is kind of an art. This is kind of a learned, right? You have to learn how to do this, right? So you have an error in Python. This is the stack trace, essentially. So this, you start from the bottom, right? This is the method main, right? Main called this, and then in file main p while main app.py line 8, right? For header in headers, and then in sniffer py on line 28. So we're going to go here, right? Because this is where we're setting the buffer size. So let's go there first and see if we can't change the buffer size. So that's Sniffer. Come down here in the sniff method. Let's say we set this to 32 like it recommends. And then we run this program again. And then we ping. And then, like, come on, man. We're getting another error? Really? Come on. So command, save. Control C, right? So essentially, you stare at this long enough, right? We're going to cut to the chase here in 1 second. It says struct error L format requires a number, essentially the way you read this, that's greater than 0 but less than 4, right? And you look at that and you're like, well, that looks familiar. Okay. That's like the size, I think, of an integer. All right, so essentially there's a problem with his code right here where he's declaring these types as unsigned longs. Now a long is longer than an int, okay, on most systems, right? A long is longer than an int. And of course it is, right? But now that doesn't mean that all systems treat int, not that the actual type of a long and an int is different. It depends on the system, right? I think. Well, I'm pretty damn sure, right? So a long is generally considered to be 64 bits. On a 64-bit machine, right, an integer would be an int. But a long might be an int as well, right? But on a 32-bit machine, a long might be 64 bits, and an integer might be, well, it would be 32 bits, right? An int would be 32, a long should be 64. But on some machines, an int and a long might be the exact same length, right? Depending on the implementation. I'm sure that you guys who are better at this than I am will throw some comments down there in my comment section and clarify this issue for me, either positively or negatively. I welcome either one, quite honestly. So you're like, well, what the hell, man? What do we do to fix this thing? So now I'll say this. You do not see this problem. Like on Windows 10, I didn't see the issue, right, when I implemented this in Windows. But this is on a Mac, Sierra, right? Not High Sierra, but Sierra. So what I had to do was this. I had to go into my IP class, come up here to these types, and change this from an unsigned long to an int, unsigned int. Okay. Save. Okay, now notice I didn't change that back from 32 to 20, but I will here in a second. So let's go back to iTerm. Okay, and let's run this. Okay, so up arrow. All right, let's do this. Let's Control C. CLS. All right, so we're going to do Python, and we'll ping. And now we get the expected output, right? So that error right there with these different lengths of those types across different Python implementations on different platforms, Windows versus Linux. Now, in my class, my students with running Linux ran into the same issue with this type as I did running on Mac, right? So I can verify that it is in fact a problem. But on Windows machines right now, even this code that I've just modified, if you take the modified code, okay, and run it on a Windows machine, then it runs fine. So I can change this back to 20, right? Back what the original book had it. And I'll run this again. And I'll ping. And now we have a working program. Okay. Okay, so that's section. That's the taking IP, right? Well, let me stop those programs. Control C. Okay, this one's already stopped. So going back to the PowerPoint. Again, we're working through chapter 3 of Blackhat Python by Justin Seitz, published by No Starch Press. It's a great book, right? If you want to learn how to do some Blackhat Python programming. And we're taking his chapter 3 Sniffer example, which is essentially implemented in one big old long monolithic script. He's using classes. We're taking the Python 2 script and we're changing it to Python 3. And so far we've implemented the ip.py. I've created a new class which he didn't have called sniffer.py, and I created another module called mainapp.py. And so now the only thing left to do, at least that's the last thing I'm going to do, is implement this icmp.py. And I'll have to make some modifications again to the program in order to implement. But because the program is organized in this fashion, the modifications are really not that hard. Okay, so for the ICMP conversion or implementation, stick around for the next session. Continuing on with the Python monolithic script conversion from Python 2 to Python 3. The next section in Chapter 3 of Blackhat Python, written by Justin Seitz, published by No Starch Press, is the section Decoding ICMP, right? Now that we previously we implemented the IP class, right? He implemented the IP class. We took it, put it in a separate module, and now when we run the code, right, it looks like this, right? So let me just start the program here and just show you where we left off. All right, so we're seeing the protocol coming across right now. We're only reporting on ICMP because we're running here on a Mac, right? So let me stop this. So we're going to just proceed the same way. So where in the previous section we created an IP class, in this section we're going to create an ICMP class. And it turns out that, you know, his code is pretty straightforward. Obviously, he creates an IP class, right? All right. So we're going to have to import the same things. We're going to have to import socket. We're going to have to import struct. We're going to have to import C types. Okay. So let's create a new module called ICMP.py. And in that module, we will just put this code in there. Okay. So let's go back to Sublime. Now, I prefer Sublime, right? Editor, text editor. It's good. It's lean. It's mean, right? And then I just compile the projects from the command line. So I do this even in Windows, right? I've used PyCharm. I like PyCharm, right? Sometimes for simple projects, the IDE can sometimes get in the way. For complex projects, can't beat an IDE, right? With the debugging and all that stuff. So new file, and I will call this file save as ICMP.py. Right, ICMP.py. And I'm going to take IP. I'm going to come up here, and I'm just going to copy this stuff because I'm going to need it anyway. Saves me some typing. And I'll move this tab over this way because I know it's my last tab. Okay. Now we're just going to choke up a little bit. Come down and scroll up the background. Okay, so class, just like he's got it here. Class ICMP structure, so it inherits from structure. And then he has another fields, which is a list. All right, so type, comma. This will be, I'll do 2 tabs over, C_ubyte. Oops, that should be a comma. All right, and then he has code. Remember, he's just taking this stuff from the header definition. Okay, C_ubyte. Checksum. Oops. Checksum. C_u short. Okay. Unused. C_u short. And next hop MTU. C__u_short. Okay, let's check this, make sure we got everything fine, and then let's get rid of these extra lines here. So type, so we have underscore fields underscore, not 2 underscores, just 1. Parenthesis type, comma, C_ubyte, code, C_ubyte, checksum, C_u short, unused, C_u short, and then next hop MTU, C_u short, Then he has a new method. So def. Let me just put some lines in here. Okay, def double underscore new. Okay. Okay. Self and then socket buffer. Socket buffer. Return self dot from buffer copy socket buffer. Okay, and then his initialization, his constructor just has pass, right? So we'll just implement it just like he has it there. Self socket underscore buffer pass. Okay. Now that's it for the ICMP class. We want to take a look at that, make sure we got everything in there correctly. Okay, so we save that one more time, and all right. So class, let me pull up my here. All right. So we have fields, class ICMP structure, fields, type, code. Then we have the new method, and we have the constructor, self socket, pass. Okay, so now we're going to figure out, like, okay, now how is he implementing this or integrating this? Now that we have our ICMP PY class, we need to integrate this into the sniffer.py program, okay? And in full disclosure, my wife just got home from practice, and so she's taking a shower. So that's why you hear the background noise. Okay, so all right, so we take a look at the code here, and we've got this new class, right, that he's provided for us. This is going to be printed in the, this is what's already being printed, right? So we're already printing this in the main. So in the main, we're doing this, the main app class. What we're going to do is, while we have that header, right? So we're in this for statement. Let's go to the main app class, and we can walk through the integration piece here. So we're going to go to main app. Here's main app. And you see where it says print protocol. So that's where we're at right here. We're at this statement right here. So we're in this for loop. So print protocol, header protocol. He's calling it IP underscore header, right? I call it header. And then we're going to do a check. We're going to do a check, and we're going to say if, okay, header dot protocol equals ICMP, right? That's straight from his book. Okay, so if that's the case, now the question becomes, how do we calculate this, right? Where do we put this code? So what we need is, we're going to have to create this offset. This is going to go into the sniffer. Okay, this is going to go into the sniffer class, but it's got to go into a new method, right? The question is, we have this variable defined in the method for in the sniff method, and we have this variable defined in the sniff method. So let's go take a look at that, and you'll see what I'm talking about. Sniffer, sniff method, right? We have, see where it says IP underscore header here, right? IP underscore header. So in the sniff method, we have IP underscore header, right? So what we need though, since we've created this, what we need to do is actually make this available to any other method, right? So we need to turn raw underscore buffer into self dot raw buffer and self dot IP header and self dot raw buffer and self dot IP header. Okay, so now the reason why we need to do this is because we're going to come down here and create a new method. Let's come here. We're going to say def, and I'm going to call it get ICMP header self. All right. I think that's probably all we need, just get IPM header self. Because then we're going to take this code that he's got here, right? And we're going to say offset buff raw. So this will be offset equals self dot header, right? So let's pull this up. All right, let's scroll this up so we can have a better view. All right, so offset equals self dot IP header. Again, we're going to make a new method here. IP header dot IHL times 4. Okay, and then buff, I'll just leave it as buff, equals self dot raw buffer set offset plus size of ICMP. Okay. All right. And then he creates right here on number 4 ICMP header. Okay, so ICMP header equals, and then this is where he creates an instance of the ICMP class, ICMP buff. Okay, now we're going to have to go up here and do just like we did for the IP class, and we're going to have to say from ICMP import ICMP. Okay, hit return. Well, maybe not so many quite returns. Okay, command save. Now we can go back to our main app and we can see what it's doing here, right? So here he's got the print, right? So print ICMP. This is what we're going to implement now. We're going to say, let's go back here. All right. Look, if, okay, so so what he's doing is he's checking if IP header protocol equals ICMP. So we've already put that line of code. Okay. Now, before we go further, right, we could always say, we could always do a test here, right, before we actually implement anything else. We could just simply say print yes, it's ICMP, right, just to do a test. All right, so let's go ahead now and just run the sniffer and do a ping. Oh, I got to do the password, so. All right. Oh, okay, so now we get this whole thing again, right? So C underscore U short. Next top MTU, C U short. Oh, invalid syntax. Oh, I forgot a comma, evidently. So let me go back here. ICMP. How'd you guys let me do that? You guys are supposed to be watching what I do. All right, so let's go ahead and just tab those guys over so it's all evened up. That's a beautiful thing about programming, though. If it doesn't work, it doesn't work, and you gotta fix it. All right, so let's go back in here. Okay, so now we see, right? So that's our little test. It's just verifying that, yes, it's ICMP. Yes, it's ICMP. All right. So then that quits. Let me go back and stop my ping. Control C. Now, what are we going to do? Let's go back to the code, right? So we're going to add this little print statement here. So we add that in the main, so main app. We can take out this test now. We don't need that. We're just going to say print. ICMP type %d code %d %, and then oh, what we have to do is we have to do this. We have to say ICMP header equals sniffer dot get ICMP header, like that. So you see where that comes from, right? So in our sniffer class, we added a new method called get ICMP underscore ICMP underscore header, which uses the ICMP class to return, right? This is an instance of ICMP, right? And we go back to the main app, and if the protocol is ICMP, then we want to just create, right? We want to get the ICMP header and then print this stuff out. So now we're here, right? So now we can say ICMP header dot type, okay, comma, ICMP header dot code. Okay, now we can try test this. Control, no, save. All right, so let's go into the console and we'll run it now. So we're going to run that program and, oh, yeah, okay, that's running. And then ping. Oh, it says name of size of is undefined. Okay, so ICMP. This is in sniffer.py. Oh, it says, what is the actual error? It says buff equals new SIZEO. All right, so let's go back to his code, make sure we didn't plus size of. Okay, let's do this. Oh, I think I know what the issue is. So we're using size of in sniffer, right? And we need to have C types from C types import star. Now it should work, right? Because we have it up here, C types, right? So because we had to put it in sniffer because we're using the size of. Okay, so let's just go ahead and run this. Okay, try it again. Oh, it says none type. Okay, so ICMP header dot type TYPE and ICMP header dot code. Okay. None type object has no attribute type. All right, so let's take a look at that. I guess we could shut down the ping while it's going on there. Control C. So this is in our main app.py. Okay, so main ICMP header.code. Let's go to ICMP header. I'm getting dizzy just clicking on all these windows here. All right. ICMP. TYPE. UByte. Let's go up here. It says UByte, UByte, ushort, ushort, ushort. So this is type, code, checksum, unused, next hop MTU. All right, so we go to, we're just troubleshooting now. ICMP header.type. Okay. A little bit mysterious, but I figured out what the problem was. It was a simple case of not returning a value. So I had to come down here to the get ICMP header. And the very last thing I have to do is I have to say return ICMP header. Okay. Now let's run it. So let's get into iTerm. So we're going to go ahead and do sudo main password. Okay, and let's start the ping. All right, so it looks like it's working. All right, now we get type 0, code 0. And I think at this point, this is all I'm going to do. I recommend if you want to complete this example, right, the next section talks about, oops, not that one. The next section of this decoding ICMP talks about, net address module, right? So if you want to add the net address module to finish this example up, go ahead. That gives you something to practice on. But anyway, this should have been a good example. All right, so what did we do? Just to review, we took a monolithic script that he's working on. Now this code, once again, comes from the Blackhat Python book, Python Programming for Hackers and Pentesters, written by Justin Seitz, published by No Starch Press. And we've been following through the book in chapter 3. He has everything in one big old module, right? He's created classes, he's used classes, but we took the classes and put them in their own individual modules. So we created an IP module, an ICMP module, and then I created a new class called Sniffer, and everything runs from the main app.py. So I hope you enjoyed this video, hope you found it helpful. And please subscribe. If you haven't subscribed, I need all the subscribers I can get. And if you have ideas for videos you want me to make, please send them to me at rick@pulpfreepress.com. That's rick@pulpfreepress.com. Happy programming. I'll catch you guys later. Thank you very much.